All right, so we're going to first look at the cosine graph here. I've chosen number 1 on the review sheet. And we need to list out everything that is asking for the amplitude, period, and radians, phase shift, and midline. And so you want all four of those answers and write them out. The first one we're going to look at is the amplitude. Remember, your amplitude is the absolute value of A. And so my amplitude here is 2. Then I am going to look at my period. My period is 2 pi over the absolute value of B. So in this case, it is 2 pi, and my B here is 1/3. And so I am going to keep change flip, and that's going to be 6 pi. My phase shift here, that is negative C over B. My C here is negative pi over 2, so we're going to say positive pi over 2 over B, which is 1/3. We are going to keep change flip, so we are going to get 3 pi over 2 here for my phase shift. And my midline here is just D. So my midline here is D. In this case, y equals 2. All right? Now I am going to have to change this graph just a little bit because I do have to, I don't have enough here. So on your quiz, you will have enough options here. So before I get started, I'm actually going to change my numbers here on my number line. So I'm going to make this 2 pi. I'm going to make this 4 pi. I'm going to make this 6 pi, and I'm going to make this 8 pi. All right. So let's look at what we need to do first. The first thing I always graph is my midline. That's really easy. And I am going to do a horizontal line at my midline to start my graph. So I'm going to put my midline there. And then I'm going to look at where this graph should start and where this graph should end. So normally I have a period of 6 pi. Normally I would start at 0 and I would end at 6 pi. However, I have a phase shift of 3 pi over 2. That's like 1.5 pi. And so I need to move my starting point 1.5 pi, which would be about right here. So this is my new starting point. Normally I would end at 6 pi, but I need to move it 1.5 pi, so that's going to be about right here. So I have a new starting point, a new ending point, and so I need to cut my starting and ending in half. So my halfway point would be about right here. Then I have a first quarter and a third quarter. And so once I do that, I know where my starting, my first quarter, my halfway, my third quarter, and my ending is going to be for this graph. So now we just look at what type of graph we have. We have a cosine graph, all right? And so what does my cosine graph look like? Well, I start at the altitude, or my amplitude rather. My amplitude is 2 above my midline. So my amplitude here, I'm going to start at 4. That's 2 above my midline. At my fourth quarter, I am going to be at my midline. At my halfway point, I am going to be below my amplitude, 2 down. At my 3/4 mark, I'm going to be midline, and I am going to end at my amplitude. And then I'm just going to connect those with a curve. So I'm going to curve that around, and that will be my cosine graph. Now let's look at number 7. Number 7 is a sine graph. And I do want to point out, we talked about this, but this one up front is just your D. And so you can actually move that to the back. And you can just see that that is exactly the same thing as having it in front. It is literally just adding 1, whether it's in the front or whether it's in the back. So now we're going to do the same 4 things. We are going to do our amplitude, which is our A. Our amplitude here again is 2. All right, we're going to do our period. Our period is going to be 2 pi over my absolute value of B, so that is going to be pi. My phase shift, once again, my phase shift is going to be negative C over B. C is negative 2/3, so we're going to say positive 2/3 over B, which this actually works out to pi over 3. So we end up with 2 pi over 6, which reduces to pi over 3. And then our midline is that D that we just moved to the back there. So y equals 1. So once again, I'm going to start by putting my midline on my graph at that positive 1, so that I have a starting point for this particular one. And then I'm going to look at my period. So normally I would start at 0 and end at pi for this one, but I have a phase shift of pi over 3. And so I am going to move it 1/3 here and 1/3 at the end as well. So I have a starting and ending point. I am going to do my midpoint. It's going to be, and you can just eyeball it as long as you're approximate, 1/4 and 3/4. So I'm going to start here, which for a sine graph is your midline. This is my first quarter, which is my amplitude. My halfway mark, which is back at my midline. My 3/4, which is my lowest amplitude, and I'm going to end back at my midline. So we're going to do all of that for this particular sine graph. So I start at my midline. My 1/4 is my amplitude. It should be 2 above this line. So my 1/4 is going to go all the way up to this 3. At my halfway, I'm back at my midline. At my 3/4, I'm 2 below my midline, which is down to this -1. And I'm going to end back at my midline. And then I'm going to curve that graph. All right, let's look at this last page here. This last page all has to deal with the unit circle. So you will get a blank unit circle. 13 and 14, they really just give you the trig function. So they give you the xy value off of this unit circle, and they want the radians that gives the answer. Remember, for sine, you're going negative or positive. For cosine, you're going first or second quadrant. So they want the sine of -1, so the inverse sine of -1 here. So I'm going to look at the first quadrant. These are all positive. Fourth quadrant, these are all negative. Now remember, for sine, you're really going to use 0 to pi over 2 and 0 to negative pi over 2. So this is negative pi over 2, which means this is negative pi over 6, negative pi over 4, negative pi over 3. That's how you're going to look at this unit circle when you're using sine, positive and negative. So if I'm trying to find the y value, that is a -1, that's right here. So my answer here is negative pi over 2. Negative pi over 2. And so that is why your answer ends up being negative pi over 2, because on the unit circle, the y value that gives you a negative pi over 2, -1 is negative pi over 2 right here. All right, that's what we do for sine and for tangent. All right, let's look at cosine. Now remember, cosine, we use the first and second quadrant, so we don't have to use the negative angles. We just keep going all the way around. So they want the cosine value that is negative square root of 2 over 2. That's going to be a pi over 4. So we're going to say I'm looking for the x value of negative square root of 2 over 2. Here's a positive square root over 2. We're going to look around. Here's my x value that is a negative square root of 2 over 2. What angle gives me that? 3 pi over 4 gives me that. So that is how 3 pi over 4 is my answer. Let's look at the last two. These are the inverse composites. So here I am taking the tangent of the inverse tangent of square root of 15 over 15. For tangent, the only things that cause issues are 3 pi over 2 and pi over 2. Those are my only issues. This has a 0 in the denominator, does not exist. This has a 0 in the denominator. So as long as it's not one of those, this is going to be within my domain for this guy. So these just cancel each other out. And your answer ends up being the original of what it asked for. Let's look at sine. For sine and cosine, the only issues I have is if it's outside of my domain. The domain for cosine is from positive 1 to negative 1. The domain for sine is positive 1 to negative 1. So as long as it's within that domain, we're good to go. However, look at this one. We want the inverse of sine of 3. 3 is the y value they're talking about. The biggest y value I'm going to have on this particular unit circle and on any trig function, the biggest sine value I'm going to have is 1. This is bigger than 1. So the inside of this function does not exist, which means the whole thing cannot work. So your answer here is just that it does not exist.